So this is the MP8 overview. So for MP8, you're going to be building a weather microservice. So as part of the weather's microservice, there's going to be 3 different pieces that we're going to be thinking about in this application itself. So the first piece is going to be an API that we don't control. So the second piece is an API that I wrote for you. And the third piece is going to be an API that you are going to be building yourself, or the app piece that you're going to be building yourself. So basically what you're going to do is you are going to build a microservice that finds out what the weather is the next time any class meets at U of I. And I think the best way to show this is to actually just run the microservice. So I've got my solution right here. So I'm going to go ahead and run my solution, Python -m flask run. And what this solution is going to do is I'm going to go ahead and bring up this in my web browser. And we've got weather of your next course meeting. And you're going to enter any course. So like 240 is the course that we're in right now. And what I'm going to do is I'm now going to launch the second microservice that has to be running. So the course's microservice is code that I provide for you. So this is all the provided code. And I'm just going to run this server itself by doing Python -m flask run. And now I have 2 different services running on my computer. Notice that this one's running on port 24,000. And so port 24,000, that's configured by the environmental variables. So port 24,000 is running the course's microservice. Port 5,000 is running the web app itself that I'm communicating with. So now what you're going to be building as part of MP8 is you're going to be building the app that you can pick any course. So I pick CS240 and I say get weather. And this is going to call out to several different APIs and get information so that you can calculate the weather at the next 240 meeting. So the weather at the next 240 meeting, so the next meeting of the course is Tuesday, October 26th at 12:30 p.m. The forecast that I was able to pull this information from was October 26, 2021 at 12. So this is the forecast for 30 minutes beforehand. It's the best forecast that we have. And it's going to be 56 degrees when you're heading to class tomorrow. And it's going to be mostly sunny outside. So this is what's required as the end result. And how we get this is going to be a combination of a lot of different services, which I'll go over in a second. But just to prove this, so 225 is another course. So CS225, let's see if 225 works. So the next meeting of CS225 is Wednesday, October 27th at 11. And it's 48 degrees. So we've got a lot of, so I could pick any different course. Let's see, is 473 in person? Looks like 473 is in person. So 473 meets at 3:30 p.m. The weather forecast I used was the 3 p.m. forecast, and it's going to be 58 degrees. So it's going to warm up and it's going to be sunny at 58 degrees. So what I have is I have a microservice that is all the input that you need to give to the service that you're building is a course name. And that's the only input you take from the user. And you've got to figure out all of the other information yourself through the use of other services. So what we have provided for you is we have provided the, so there's a question in chat. Why is the forecast time at 2:25, 10 a.m.? And I think that actually may be, so I made a change at the very end in my solution code. And I think the correct answer should be 11. So I'll change that in my solution. It's actually a less than equals versus less than problem. So I would need to change that in my solution. So so that's an error in my solution that I didn't notice just because I was changing things at the last minute. But I will get that fixed as soon as I'm not screen sharing. So great question. So what we have provided for you is we have a courses microservice that's provided for you. And this microservice is going to tell you the schedule that every single class meets. And what I like to do whenever I have a microservice is start interacting with it. So the course microservice, the way we're going to get course scheduling information is we have a microservice where we give a subject and a number. And we know that this microservice is running at localhost port 24,000. So what I can do is I can go to localhost 127.0.0.1 port 5,000, or sorry, 24,000. And then at CS240, let's see what CS240 gives us. This is somehow I wanted to go to the secure one. Awesome. So the course is CS240. The start time of the course is 12:30 p.m. And the days of the week it meets is Tuesday, Thursday. If I go to 225, then I see 225, it meets on Monday, Wednesday, Friday. It meets at 11 a.m. And the course is CS225, of course. So when we have a course, the course's microservice is going to give us back a reply that is going to let us know that when the what the course name is, the days of the week it meets, and the start time of the course. And then if the course doesn't exist, so for CS300, for example, we can see what happens when we ask this, and we get the course is still CS300, and then it returns a JSON that has an error that says no course data is available for CS300. And we can look at the source code because the source code for this is provided, and we can see that it is going to report an error every time there is an error. So there's one error that gets reported if the course number is not a number. So I guess if I do 30x, we see course number 30x is not a number. And we see that then the status code is 404, that it's not found. Similarly, if there's no course data available, we see the status code is 404 here. So we get an error message if the course is not found. So if a key error exists in the JSON, we know that that course doesn't exist. And otherwise, we're going to see a start time and a days of week inside the JSON. And you don't have to ever look at this code, but I provided this code for you so that you can see a microservice that I built that went and gathered the data from the Illinois course catalog. So you're going to be able to get this data. You just have to query the server, for example, CS240, and you're going to get back the information about when 240 meets. And what you're going to do is you're going to have to now use this data to then calculate based on the current time of your current computer, so of the web server, what is the next time that that course actually meets. So right now it is Monday, October 25th. So the next meeting is October 26th. If I were to run this microservice at 6 p.m. tomorrow night, then the next meeting would be on Thursday, October 28th. So you have to look at the current timestamp of the computer and figure out when is the next meeting for this particular course. So that's the first part, is to understanding, getting course microservice data, figuring out when the next course meeting is. The second thing is you've got to get the weather, because that's actually the goal of the app. That's a value add that you're actually adding. So to get the actual weather, you're going to need, and then I've provided some code right here to actually get the data for the actual course itself. So just to kind of finish up the course part, since I provided this code, let's look at what happens when this code runs. So I'm going to go ahead and open the app.py here. And in the app.py, you're going to be doing the post weather function. So let's see if I get a course. I'm not even going to worry about parsing, so I'm just doing the provided code. Let's make sure the course's microservice URL is defined. That looks great. It's defined exactly right. So we see that that's in the environmental file. So, and then subject, I'm just going to say my subject, I'm just going to hard code it to get something to run. Subject is equal to CS. Of course, we need to actually parse it from the course itself in the real version. And then I'm going to say number is equal to 240. So then it's going to combine subject and number into one big string. It's going to get the JSON. Then I'm just going to go ahead and print it out in my console. So what I'm going to do is I'm going to stop running the solution code, which I'm running over here. And now I'm going to instead run this microservice that I just programmed. So I'm going to go ahead and create a new console because I've got to keep the course microservice running. So I have a new console running, and I'm going to do Python -m Flask run. And now I've got the new version of this microservice running. And now I can go ahead and load this page and do CS240. And now when I post to weather, now I don't have the complete solution. So now I see there's an error that happens, which is because I did not return, I returned 500 here. So the actual application, the front end, is displaying an error. And that's because the front end didn't just get the information it needed back. But I do see that I get the printout. So I printed out the course GPA data, and I can see that these lines of code actually successfully got the JSON from the course's microservice. So this is already provided for you. So all of this is provided in documentation. You should be able to get here just by running all the microservices and launching things and testing things out. And then here, because I'm not actually using the course input, I could put whatever course I want. And even when I put a totally bad course, I'll see that it still gives me the information for CS240, and that's because I hard-coded CS240 here. While in reality, a course that is gibberish like this should return an actual error. So that is the first piece, and that's all provided for you. What I really want you to do is first understand how these microservices work together. The fact you have to launch both these microservices, you have to have both of these things running. The second piece that you're going to work on is you're going to have to get the weather data from the National Weather Service API. So the National Weather Service provides a whole bunch of documentation on how to use their API. They provide a number of different examples on how to use the API. They provide the complete API specification so that of all the different functions that you can use to get data from their server. So like any other API, what I really recommend is that you run this API in your browser so that you can actually see how it works. So it says the API is located at weather.gov. So I'm going to go there. I see that it gets a response. I'm going to go ahead and test out one of these specifications. So it looks like Git Alerts seems to, oh. So it needs a bunch of different parameters. So I could try out those alerts, but let's see if there's one that doesn't need any. Okay, so glossary doesn't need any parameters. So I'm going to go ahead and do /glossary. And I see that I get a bunch of data back. So I'm communicating now with an external API. And what you're going to need to do is you're going to need to read the documentation and understand, how do I get the weather for a given period of time on a, once I figured out the period of time that I need to get to grab the weather for my course. So you're going to have to look at the documentation, dive into the API, and figure out, how do I get the weather forecast for a particular hour? And I give you the GPS coordinates that you should use. So this is the GPS coordinates for basically are right near the KIF building, the 2035, our actual classroom building. This is the GPS coordinates very close to that building. You can go ahead and just use those GPS coordinates for every single forecast that you pull. If you need GPS coordinates, you need to pull the information for the specific hour where the course meets. And you must use the course's microservice. So don't copy and paste the code from the course microservice into your own microservice. You need to actually launch both microservices, call out to get the weather from get the course data from the course microservice. And then what you need to do is you need to return a formatted JSON. So you need to return this dictionary that needs to mention the course. It needs to mention the time of the next course meeting, the time of the forecast you actually pulled from, the temperature, 6 degrees, and the short forecast. So when I made this MP and I ran my code on CS240, the forecast was 60 degrees then. I think if I remember right, it was 56 degrees when I ran the solution earlier just now. So at 56 degrees, it's a little cooler now than we were originally forecasted. And if you get any sort of error, return a 200 or 400 error. And then you're going to have to actually do this relative to the date time. So I linked you to the Python documentation for the date time function. So you can explore their documentation on how to work with dates in Python. And you don't need to account for holidays or any other, the end of semester, any other weird things. Like if the course meets on Tuesday, Thursday, if it's a Wednesday, it should report that Thursday. If it's a Friday, it should report that next Tuesday's weather. So no matter what it is, you should just report the weather for the next time that class would meet based on the response you get from the course microservice. And as mentioned here, you can actually test out the course microservice just like what we did here, where you have a start time, days a week, and the course itself. So I've already done all the work to actually parse out the entire course explorer to find out exactly when every course meets. And that is it. So what you'll learn is you will learn how to interact with a microservice that we built. So a microservice that I built, the courses microservice. You will interact with a microservice that is an external microservice. So that's the National Weather Service API. And you've got to do this all within one response and then format a JSON response out. So this is a very common technique to building microservice-based applications, where you're going to pull in data from multiple different microservices and then present that data in one summarized format to give the user the information they want. And once you've got this, then you have a weather forecast tool that anytime you're about to head to class or wondering what you should be wearing for the next class, you can pull up this tool and actually see what the weather forecast is, whether or not it's going to be raining or not, or sunny, and the temperature. So you've got a really useful tool that you have at the end of this, where you just plug in the class and it already figures out when the next meeting is. So that is what I have for you. So any questions about this microservice? Can we assume the course number on the front end will always follow the format CS240? No, you shouldn't make any assumptions about the format of the course number. I would say that, and that's a good question. I can add this. I would say that 240, CS240, CS240 or CS240 should all be acceptable versions of this. Like you should be very resilient to what the user inputs. So you don't have to accept 240 CS or anything weird like that, but you should, whether or not there's a space or not shouldn't matter, and whether or not they capitalize the course should not matter. All of these should be accepted because these are all common ways that people represent the course numbers. But anything beyond that format doesn't need to be accepted. Can you change the HTML? Sure, you can make it look pretty. You can put a front end on it. You should just make sure that your JSON you get back includes at least the fields that we specify. You can add more fields to the JSON if you want to return extra information, but the only thing we're going to look at is make sure the JSON return has those 5 required fields. Harry, I think CS with a capital C, lowercase s, honestly, those should be fine. Like any algorithm you create should probably either just lowercase or capitalize all of the letters. So those should get covered real fast. There's like a .upper or toUpper function in Python that will just capitalize everything. Lloyd asks if there's any information about how to Docker. So in the submission instructions, is that what you're finding, Lloyd? Is in the submission instructions we ask about a Docker?
Yeah, that's what I was, yeah.
That honestly is leftover. You don't need a Docker container for this one. Let me remove that right now. So yeah, Andrew, same answer that I gave to Lloyd. You don't need a Docker container. And I am right now, I'm opening up the MP8 markdown file right now. And yeah, that was honestly me. Oh, it looks like it's already, yeah, this has already been changed. I think that the website may have just not deployed. So it's actually changed on the source code for the website. There's been weird issues with the deployment box that I've been using today. Like engineering IT's had some weird things. So I'm running CS240. Okay, let's see if this redeploy made it happy. I will get rid of. So what I'm seeing on my screen, just to kind of give you a heads up and why I am like not sure why it's, is this is the text that we have on the actual MP description. So this is, you'll see this is MP8 index.html. When you completed the program, double check that you've ran above. So there's no references to the Docker there. And I'll figure out offline why the website's actually not getting updated and not getting built, because it looks like here that, so Nikhil, the TA, actually removed it from the reference, and it looks like the website should be updated, but I'll fix that offline. So no, the big idea here is no need to worry about any Docker containers for this MP. You'll have Dockers back in MP9, but there's no Docker containers in MP8. Any other questions?
Professor.
Yeah.
Are there GitHub test cases for this MP, or do we have to test that ourselves?
Yep. So this is, yeah, we want to make sure that you are understanding what your code does and have trust your own code. So there's no automated test cases for this one. You're just getting to build it out yourself and testing it out yourself. But I did have some suggested test cases in there for you to look at.
Sounds good.
Any other questions? So if there's none, I just have one question for you, which is, was this useful? So you show a poll up on your screen on whether or not this session was actually useful, or did it help you out or not so much? Cool. All right. People felt like, yes, seems useful. Awesome. So that's MP8. Have fun with it. Enjoy it. I think it's getting close to actually how you're building real web applications. Like a lot of what you're doing is building microservices that interact with other microservices that then gives you some information to the front end. So this is, if you wanted to jazz it up, you could put a React front end in front of it. You could have the forecast images, you can have the temperature in big pretty fonts. Like you could you could imagine what the front end might look like. You get a designer involved. You could really jazz up the front end. That's sort of beyond the scope of systems itself. The systems, how do we get the data to the front end? How do we manage the middleware and back end? But you can imagine the front end can really be jazzed up. So that's all I've got. Thanks for coming by.